Hey guys, today I'm going to go over with you how to type out unit analysis or factor label method on a Google Doc. This turns out to be a lot cleaner and neater than trying to legibly write it out, get your camera lined up, and take a good picture. Though we'll always accept either way. Once you get used to using the equation editor, it's really not so tough. So the first thing we're going to do is we're going to look at this little lead fishing weight right here. You go. And we're going to see what we can figure out about it. I have put it on a triple beam balance, and as you can see on my screen here, the fishing weight's mass is 56.70 grams. And I've gone over to the periodic table, the same one that's included in you guys' assignments in the past, and found out that lead has a mass of 207.2 grams for a mole of lead. So our question, how many moles of lead do I have right here in my hand? So let's show the work in this Google Doc. We'll get my cursor here. And the first thing I'm going to insert equation. And that opens up our little equation editor. And I'm of course going to start with the mass that we've been given, 56.70 grams. And I'm going right up here to this cool little bar. And the second one I'm going to say times. So we're going to multiply. And now we've got to insert that conversion factor that goes in like a fraction. This is why the equation editor is easier. It lines stuff up. You could do this by highlighting and subscripting and underlining, but it never looks quite right. So in these choices, if you go over to this one, math operations, and you pick the one that looks like a fraction, you'll see our little cursor jumps up to the top there. And now I can say, wow, I know that in 1 mole, and once I'm through typing on the top, I'll reach up and hit the tab button, and the tab will jump down to the bottom, and I can say that I know that 1 mole of lead has 207.2 grams. Now once I'm through with the fraction thing, I hit the tab key one more time. And you notice it looks almost like the cursor disappears. It's really over to the right. And I'm ready to type the equals mark. There's really not an equals mark to pick up there. So I'll just type equals. And then you go to your calculator. I've got this one that comes up from the school computer. And let me move it over here out of the way of the video. And I can go, okay, 56.70, and since 207.2 is on the bottom, that means divided by 207.2 equals, and whoa, get a pile of numbers. But remember our significant digit rules. There's 4 significant digits in 56.70, and there's 4 significant digits in 207.2. So that means 1, 2, 3, 4. We've got a round to right there. 0.2736, because that leading zero doesn't count. So 0.2736, I'll put my cursor back over here and go 0.2736. And of course, we'll notice that the grams on top and grams on bottom cancel out. So our units are moles. And we look up. The question was about moles. Our units are about moles. So we're on the right track. That's probably the right answer. Okay, so that's how we would type that in. Now, a lot of times that's not enough, and we'll ask the question, how many atoms is that? Well, we can figure that out also. All we have to do in our little equation editor is go insert an equation one more time, and we'll start with what we just figured out, 0.2736 moles. And we go, now times, and then good old Avogadro's number. Now remember, this is again a conversion factor, so it's going to be a fraction. We're going to add in a twist. We know that Avogadro's number is 6.022 times, we're going to do times, and then it's 10 to the 23rd power. So what I'm going to do is I'm going to go back over here and select this x to the b, this thing that lets me do an exponent. I'm going to click on it, and now I can type 10, and then when I hit the tab key, bam, it jumps up and lets me give it an exponent. If I hit the tab key one more time, bam, I'm out of exponent mode. So we know that's that many atoms. And now I'm ready to go to the bottom of the fraction, hit the tab key again, bam, and I know there are that many atoms in 1 mole. Okay, my fraction for that conversion factor is complete. So I'll hit the tab again, hit equals, and then go, wow, I just got to figure out what that is. So let's go back to the calculator again. Here's my answer from the first one. I can just leave it there. And this time, both of my numbers are on the top. So I'm going to go times 6.022. Now, if you get in the habit of hitting times and 10 and exponent, quite often that will mess you up on the calculator because of order of operations if you don't use a lot of parentheses. Instead, all calculators that are scientific calculators have the ability to do scientific notation. In this case, it's EXP. Some calculators have a button or a mark that says capital E, capital E. This one is EXP. We hit it, bam. You see the little E plus, that means times 10 to the something. So now all I've got to do is enter the exponent. That is 6.022 times 10 to the 23rd power. That's Avogadro's number. So now all I got to do is hit equals. And we see, holy crap, Batman, that is a huge number. Even rounding to 4 significant digits, that'd still be 164,700,000, and you can see we'd be typing zeros. Chances are we wouldn't count, we'd type. The potential to mess up is terrific there. So instead, we don't want to write that. We want to write it in scientific notation. If you're using your own calculator, you should be familiar with your own calculator. You know how to put it in scientific notation mode. If you're using this one on the school issue computer, just click on this F to E button right there, and that puts it in scientific notation. Now we can go 1, 2, 3, 4 significant digits. Now the next number is a 9, so that's going to round to 1.648, and there's our exponent. So we'll type it in. We'll put our cursor back here where it's supposed to be, and we go 1.648, and then we'll go times, and then I won't use the exponent function, and type 10, hit my tab button, 23rd, hit my tab to get back out of it, and I can type my units, which are atoms. Remember, no units, no credit. But that shows you how to use the equation editor in order to type these conversion factors. Now, you may decide you want to see it one more time. Of course, this is a video. You can always pause, rewind, and everything. But I'll show you something. I want to show you one more because most of the time we expect you to put all your steps together. We don't expect you to do one multiplication, then another, then another, then another. We expect you to string it out. So let's do a simple two-stepper. Now, this other thing that I have right here, this is an iron frying pan. Yeah, like your grandmother's probably cooked in, and we have it at the house. I love it. This is a nice small one. You can see it's smaller than my face, and it has a mass of around 1 kilogram. In fact, when I put it on an electronic balance, we see that the mass that I got was 1,000 grams. Now remember, those zeros normally aren't significant. The way I want to show that I really measured them, remember we learned there were 2 ways in class to show the last zero was significant. We could put a line over the top or put a decimal. On the computer, putting a line over the top is not practical, so I just do 1,000 in decimal, and that means all those are significant digits, grams. Then I went to the periodic table, I looked up iron, Fe, and wrote 55.85 grams. So let's figure out how many atoms of iron are in this thing right here. Okay, so we'll start with the mass that we have. So we're going to go insert equation, and move the screen up there. And I'm going to start with 1,000 grams. And I tell you, I'm going to make my units better this time. It's much better when it's descriptive. So 1,000 grams of iron. I'm just going to type the Fe. And you'll see a little later on in the next few lessons why we've got to start keeping track of what elements and what compounds we're talking about. Right now, it just seems like I'm typing extra, but believe me, this is important. So I've got my mass. We're going to tell it multiply And we're going to do our first conversion factor. So I'm going to do that. And we know that in 1 mole of iron, see the Fe, now I've got what I need on the top. I'm going to hit the tab, and I know from the periodic table it's 55.85 grams of iron in 1 mole of iron. The tab to finish out that. But I'm not going to stop there. You see, I need to know atoms. I don't need to know moles. And right now, the grams will cancel out. My answer will be moles. So we need one more conversion factor. Now that we're down to moles, we can add a new one. I'm going to put my little fraction in. And I can say that I know there's 6.022 times. And remember, I'm going to tell it I'm going to use a fraction this time. I'm sorry, not a fraction, but an exponent. 10, hit the tab key. 2, 3, hit the tab to get out of that. We know there are that many atoms. And of iron. And I'm going to hit the tab key again. And that's in 1 mole of iron. And we see now our units that'll cancel out will get us all the way to atoms. So I can hit the tab to get out of that, hit my equals mark, and then try to figure out what the answer is. So let me put my calculator back up here and clear everything out and go, okay, I've got 1,000. Now, 55.85 is on the bottom, so that means divided by 55.85. And then move this over just a little bit. We can see that Avogadro's number is on the top. So, put it back where you can see it. Since it's on the top, we'll times 6.022 exponent 23. That means 6.022 times 10 to the 23rd power equals, yay! And gracious, it's big again, but no problem. FE, bam! There we are. 1.078 times 10 to the 25th. Because again, everything is 4 sig digs. So 1, 2, 3, 4, 8 would be my last sig dig. There's a 2 to the right, so it stays there. 1.078 times 10 to the 25th. So that's what I'll write. 1.078 times, and then I'm going to have an exponent. 10, hit my tab button. 25th this time because it was big. Hit my tab to get back down to normal. And we'll notice that grams of Fe canceled with grams of Fe, moles of Fe canceled with moles of Fe. I'm left with atoms of iron. And that was what the question was. So, hey, I'm probably going to be correct here. That's how you do it. I hope that helps you. Like I said, you can do the written, but trying to get a clear picture has proven very difficult for a lot of my students. So once you get used to typing it, it's not that big a deal. But remember, with unit analysis, also called factor label, format is everything. It's got to look right. We've got to see the things canceling out, because the bottom line is if the units don't work out, you know your answer's wrong. If the units do work out, you might still hit something wrong on the calculator, but you're going to be in the right ballpark. And this is all about how to find the answer. What the answer is not all that important. It's kind of gravy. We want to know that you have this technique, that you can do this. So good luck. Hope this helps.